Hi guys, so today I just wanted to quickly hop on and give you some examples of how to write the equation of an exponential function using a table. This is something that's very important. It's really important that you know how to figure out how to write the equation of an exponential function, or even if this table the table you're given represents an exponential function. So we're just going to quickly go through two examples straight out of your workbook, straight out of the assignment I gave you on page 93. So the workbook I'll be referencing is the Algebra with Model Student Workbook by Marian, Anton, and Karen Santoro from CCSU, and this is the 2018 edition. So when you do this, when you're given a table and you want to figure out, first of all, is this an exponential function? And second of all, if it is, how do I write the equation for it? These are the steps you're going to take. So first, you're going to see if you can find a constant multiplier. So when I'm looking at my inputs and my outputs, if my inputs are increasing at a constant rate, is there a constant that I'm multiplying by from one output to the next to get my different outputs? So, in the example that we went through in our video lecture that you guys were given for today's class, we were doubling, right? The cells were splitting, and so from one day to the next, the amount of cells we had was doubling. Our constant multiplier was 2. So to go from one output to the next, we were multiplying by 2 every single time. Our constant multiplier was 2. So when you are looking at these tables, the first thing you want to look at is this even an exponential function? Do I have a constant multiplier as I'm going from one output to the next? And if indeed you do, then you need to solve for the initial value. And how do you do that, right? So sometimes it will be given to you in the table. So if they give you the input 0, right, that's the first input. That is your starting value. The output would be your initial value. If not, well, that's okay. There's a pretty quick and simple way to figure out what the initial value is. And it's really similar to what we did when we were doing this for linear equations, right? When we had our slope and we needed to find the initial value, well, we just picked a point and we plugged it into the equation y equals mx plus b. We plugged in our y, our x, our slope, and we just solved for b, the initial value. It's the same idea here. Only our equation for exponentials, right, is f of x equals a, which is our initial value, times b, where b is the constant multiplier to the x power. So we're going to pick a y and an x, an input and an output, and we're going to plug those in. We'll plug in our output for f of x. We'll plug in our input for x. We will have already found our constant multiplier b. We'll plug that in for b, and then we'll just solve for a. Okay, which will be our initial value. So, I can say that, and it might sound really convoluted, so let's actually look at an example and see how to do that. So I'm just going to pull up this is page 93 in your workbooks. Okay, I'll zoom out so you guys can see. So here we are at page 93 in your student workbooks. This would be, okay. So I'm going to start with number 6. So let me just zoom in on that for a quick minute here. Okay, so whenever I'm given a table or any situation, you guys know at this point, I always say to do what? I always say to make a movie in your head, to figure out what's going on. So I look at the title. This is called Instagram. I look at my input. They called it H for hours, and my output, L of H for likes. So we are clearly looking at an Instagram post. We've made an Instagram post, right? And we've made a table of values that shows how many likes we get over the course of each hour after we post it. Okay, so as soon as we post it, we got 1 like. An hour later, we're up to 8. 2 hours later, we have 64 likes, and 3 hours later, we have 512. So the question is this an exponential function? And if it is, how do we write the equation for it? So let's write the general equation for an exponential function up here. I think that's important, and we're going to be referring to it all throughout this. So f of x, right? Any exponential function can be written in the form of f of x equals a, where A represents our initial value, times B, where B represents our constant multiplier, to the x, which is our input. So our output, f of x, is equal to our initial value times the constant multiplier to the input power. Okay? So that's what we're looking at here. All right, so let's see if we do indeed have a constant multiplier here. I always start with the left side, and I just make sure it's increasing at a constant rate. So to go from 0 to 1, we add 1. To go from 1 to 2, we add 1. And to go from 2 to 3, we add 1. So yes, the left side is increasing at a constant rate. So now I can look at the right side, and I want to look to see if when I go from one output to the next, am I multiplying by the same value, right? Is my multiplier constant? What is my constant multiplier, okay? And there's a formula I gave you for that, right? So your constant multiplier, which we call B, is equal to y2 divided by y1. All right? So when you are calculating your constant multiplier, you want your y2 and your y1 to be consecutive points. So what do I mean by that? So let's say our y2 here is 8. Okay. Well, then our y1 needs to be the point that comes directly before, the output that comes directly before 8, which would be 1. Okay. So 8 divided by 1, what does that give me? That gives me 8. All right. Well, we know we multiplied by 8. To go from 1 to 8, we multiplied by 8. That makes sense. Well, now we need to make sure that's true all the way through, right? So let's see if that does indeed work. So you can just say in your head, okay, 8 times 8, oh, that does give me 64. Or you can plug it right into this equation. And as we get into bigger numbers, plugging it into the equation is going to be the smart thing to do, right? You might not be able to do that mental math in your head. So let's see if our y1 now, if our y2 is now 64. Whoopsie, sorry guys. If our y2 is now 64, then remember we need to look at the output directly above it for y1. So now we're looking at 8 for y1. 64 divided by 8 is indeed 8. So we are continuing to multiply by 8 here. Good, that's what we want. So now we need to ask ourselves, okay, it's a 64 times 8 equal 512. And you could plug that into your calculator, or you could plug it right into this equation. And just for consistency's sake, I'm just going to keep plugging into the equation. So now our y2 is going to be 512. Okay, and our y1 is the output directly above that, 64. And it does indeed equal 8, you guys. You could pop that right into your calculator, but 512 divided by 64 is 8. So, again, we are multiplying by 8. We do indeed have a constant multiplier, right? Every time our output, to go from one output to the next, we need to multiply by 8. So, yes, this is an exponential function. Yes, it is, okay? So now we have the challenge of writing our equation for this function. We know it's an exponential. We're happy about that. Now we need to write an equation for it, okay? We know what our constant multiplier is. And just for the sake of space, you guys, I'm just going to erase a few things here. Okay, just so I can save some space as we do the math for the rest of this. So we know that our constant multiplier is 8, right? Which means B is equal to 8. We know what our B is, but we don't know our initial value yet. So sometimes I said it'll be really easy. They'll give it to you right in the table. And indeed they do, right? They give us the initial value. When you see 0 for your input, then that leads you directly to your initial value, right? The output is 1, so our initial value is 1. They gave it to us. That was really nice in this table. They just gave us our initial value. So we know after no time has passed, 0 hours have gone by, we have 1 like. So when we first post this Instagram post, we initially have 1 like, right? No time has gone by. This must be our starting value, 1, which means that A equals 1. So now we have our A, we have our B, we can write the equation for this particular exponential function. So I always start with the general equation, f of x equals a, where a is the initial value, times b, where b is the constant multiplier raised to the x power. And then I fill it in and make it match my particular situation. So we have our Instagram situation. Our variables are h, hours, and L of h for likes. So now we need to make it match our function. So here our output is what? Well, it's L of h. Okay, equals, what's our A, you guys? It's 1. We knew that. So our A is 1 times B, our constant multiplier, which we know is 8. And we're not dealing with x's, you guys. Our input we called h. And there it is. Okay, that is the equation for our exponential function. So this one was really nice because they gave us that initial value of 1 right in the table. Sometimes, though, they're not going to be that nice. Sometimes we're going to have to work a little bit for our initial value. So let's take a look at a situation where we sort of have to work for it. So I'm going to bring us on down to number 7 down here. Let me try and get us as much white space as I possibly can. So I'm going to have to get rid of this over here. Whoops. So that we have some space to sort of work with. All right. So now, again, I'm going to take a minute and I'm going to think about what is this situation I am now dealing with, right? So I'm dealing with cell growth, you guys. It tells us right here. I'm going to take a second and just stop and think about what's happening. So we are tracking the amount of cells, the number of cells, which they called n of d, over d days. So after d days, how many cells do I have? Okay. So the first question is this an exponential function? We need to see if there is indeed a constant multiplier. I'm going to check the left side just to make sure I am increasing at a constant rate. So to go from 3 to 4, I add 1. To go from 4 to 5, I add 1. To go from 5 to 6, I add 1. Right? That is key, you guys. You need to make sure that while your input is increasing at a constant rate, you have your outputs being multiplied at a constant rate. So it is important to check to make sure that there is a constant increase over here. It might seem a little redundant, but we're mathematicians and we're careful and we're we're very precise in what we do. So it's important to check these things. So now I need to see if when I go from one output to the next, am I multiplying by the same amount each time, right? So do I have a constant multiplier, right? And remember, our constant multiplier is called b, and it's equal to our second output, y2, being divided by the output that comes immediately before it, which we refer to as y1. So let's check, okay? Let's look at our second output here, 12,150. So 12,150 divided by the input that comes immediately before it, 4,050. Okay, check to see what that equals. You could plug it into your calculator, whatever you need to do. Okay, just plug it right in, 12,150 divided by 4,050, and that gives us 3. So I know to go from 4,050 to 12,150, I multiplied by 3. Okay, well that's good. Let's check to see if that holds true for all of our points now. So for the sake of space, you guys, I'm just going to delete that so that I can keep on going here. I don't have as much space to work with this time, so I'm going to have to be erasing as we go. So now let's check the next 2 points, right? So if now our y2 is 36,450, then my y1 be the output immediately before that, immediately preceding that, which is 12,150. Does that equal 3? And if you plug it into your calculator, it does indeed equal 3. So that's good. We're getting happy. But we have just, one more jump to check to make sure that this is our constant multiplier does hold for this entire table. So now let's call 109,350. Oh, I keep forgetting to change back to the brush. Okay, so 109,350 are y1. Okay. Well, then our y2. That's our y2. Well, then our y1 would be the output that immediately precedes that, which is 36,450. And that's looking like it should be about 3, right? And if you plug it in, it is indeed 3. So that should make us really happy because now we know this is indeed an exponential function, right? We have a constant multiplier of 3. Every time we make a jump here, we are multiplying by 3, okay? So we know that our constant multiplier is equal to 3. Good information for us. So now we say, okay, when I'm writing the equation of an exponential function, I need a constant multiplier and an initial value. I have a constant multiplier. It's 3. I have my b. I'm going to write it right here. Whoops. Okay, b equals 3. But I need my a. What's my initial value? Let me change colors here. What is my a? I don't know. I don't know my initial value yet. How do I find it? Well, the first thing I'm going to do is check my table. Did they give it to me? And I check my first data point and it's not 0, it's 3. So they did not give me my initial value here. So that's okay though, because it's not too bad to work for it, you guys. And I'm just going to expand this so I have a little bit more space to work with. Just ignore this. I'm just going to get rid of it. Whoops. Because I can. So let's just get rid of this and give ourselves lots of space to work with here. Okay, so I can actually solve for the initial value. And like I said, it's very similar to what we did when we were solving for the y-intercept, the initial value for lines. We pick a point, we plug it into the general equation, and we solve for the initial value, right? It's exactly what we did before. So always start with your general equation, which is f of x. Our output is equal to a, our initial value, times b, which is our constant multiplier, to the x power, to our input, okay, the power of our input. So I need an output and an input. I've got 4 of them here. 3, 4,050, 4, 12,150, 5, 36,450, and 6, 109,350. I need a point, right, you guys? So I'm just going to pick the point that's got the lowest numbers, okay? I like to work with the lowest numbers as possible, so I make the fewest amount of mistakes as possible. So I'm going to pick the point 3, 4,050, okay? And boom, here's my x. Here's my f of x, my input and my output. Right there. Beautiful. So now I'm just going to plug all this information. I know what f of x is. It's right here. I know my constant multiplier. It's 3. And I know my, I know my input value, guys, my x. So I can plug all those numbers in and solve for a. So that's exactly what I'm going to do. Okay, so my f of x here is 4,050, right? So 4,050 is equal to a, which I'm solving for. I don't know it yet. That's what I want to find out. Times b, my constant multiplier, which I know is 3, to the input power, right? X, which I know is 3. And now I can solve for a pretty easily, okay? So let's do 3 cubed. Remember, an exponent you can think of just as a copy machine. So this means I want 3 copies of 3 being multiplied together. So 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So 4,050 equals 27 times a. And then to solve for a, I just divide by 27. And 4,050 divided by 27 is 150. So my initial value here, my A, equals 150, which means I started with 150 cells. So when I first started this cell growth experiment, I started with 150 cells, right? When no days had gone by, I had 150 cells. And then every day what happened? Well, they increased by a multiplier of 3. So every day I multiplied by 3 and by 3 and by 3, and I just kept getting more and more cells. So now I know, I'm just going to get rid of this. So we got some space to work with here, you guys. So now I know that I no longer am questioning what is my A. I know it's 150. I started with 150 cells. So now I can indeed write my equation. Okay, I can write my exponential equation. So again, I always start with the general form of the equation. F of x equals A times B to the x, and then I fill in for my specific situation. So here, we're not dealing with f of x, right? We're dealing with the variable n of d, which is just the number of cells after d days, is equal to, what's my A, my initial value? Oh, 150. I started with 150 cells, times B, my constant multiplier, which is 3. And now we're not raising it to the x power, you guys, because our variable is called d, the number of days that have gone by since we started this experiment. And there is my equation. Okay, so it's not too bad to find it. It's incredibly similar to what we did when we were, when we were solving and writing linear equations, right? We found our slope, and then we picked a point and we plugged in our input, our output, and our slope, and we solved for B, the y-intercept. It's the same concept here. Here we're finding our constant multiplier, and then we're just, if it's not given to us in the table, we're just picking a point and we're plugging in the input, the output, the constant multiplier, and we're solving for A, which is our initial value. Okay? So if you have any questions, please feel free to reach out. I hope this was helpful for you. And I hope you guys are all healthy and well. And I will see you soon. Okay, bye.